All right, in this video, we're going to look at geometric progressions. We've already mentioned earlier that the term progression has the same meaning as a sequence. So these are geometric sequences or geometric progressions. So a sequence is a geometric one if the second term is obtained by multiplying the first term by some number which we're going to call r, and the third term is obtained by multiplying the second term by the same number r. Fourth term is obtained by multiplying the third term by that same number r. So in each case, each term can be obtained by multiplying the previous term by the number r. The number r is in this case called the common ratio. So this is the common ratio. This is termed like this because from what we've just said, it means that T2 over T1, for instance, is going to be R. Similarly, T3 over T2 is going to be R. T4 over T3 is going to be R. So if you divide one term by the previous term, each time you're going to get R. So that's why it's called the common ratio. Right, what this means is that we can write T2 in terms of T1. T2 is going to be T1 times R. Similarly, T3 in terms of T1, if you want to go from T1 to T3, you multiply by R twice. So it's going to be T1 times R times R. T4 is going to be, in terms of T1, if you want to go from T1 to T4, you multiply by R 3 times. So it's going to be T1 times R cubed. Similarly, T5 is going to be T1 times R to the power 4. From this, we notice that the power of R is always 1 less than the position of the term. So this means that Tn is going to be T1 times R to the power n minus 1. And this is what we call the formula for the nth term of a geometric progression or a geometric sequence, where this is term number n, this is the first term, and R is the common ratio. All right, so that is the formula for the nth term. Now we're going to seek to derive a formula for the sum of the first n terms. So the sum of the first n terms of a geometric progression. So just similarly to the notation we used for the arithmetic progression, we're going to call this Sn. So Sn is going to be T1 plus T2 plus T3, etc., and then all the way to Tn. Now, using the formulas we just derived in the previous steps, means we can write this all in terms of T1. So T2 we said is T1 times R, T3 is T1 times R squared, and Tn is T1 times R to the power n minus 1. Now, if we multiply through by R here, which we can do, this is what's going to happen. So this side is going to be Sn times R. If you multiply this term by R, we're going to get T1R. So I'm going to write it here because it's a like term to that second term there. Multiply this one by R, we're going to get T1R squared. Multiply this one by R, we're going to get T1R cubed all the way to, if you multiply the term just before this one by R, we're going to get T1R to the power n minus 1. If you multiply this one by R, we're going to get T1R to the power n. Right, then what we're going to do here is we're going to subtract. So if we subtract this second one, so on the left hand side we're going to have Sn minus R, Sn. So this side we're going to subtract corresponding terms. So here T1 minus nothing here going to give us T1. Then here this term minus this term going to give us 0. This term minus this term going to give us 0. All the terms here are going to be identical. So if you subtract, we're going to get 0. This term minus this term is going to give us 0. And then for this one, there's no corresponding terms. It's going to be 0 minus this term. So it's going to be negative T1 R to the power n. Then if we factorize on both sides, we're going to have 1 minus R times Sn. And then this side, we're going to have T1 into 1 minus R to the power n. So from here, then we can make Sn the subject of the formula. It's going to be T1 into 1 minus R to the power n, all divided by 1 minus R. So that is going to be the formula for the sum of the first n terms. Now, whenever we divide by something, we need to make sure that it cannot be equal to 0. So here, this formula is going to be fine so long as 1 minus R is not equal to 0. So that means we're going to have to restrict R to be different from 1. Okay. Another thing, so we can either use this formula, or alternatively, if we multiply both numerator and denominator by negative 1, then we can express this formula in that form. Okay, but for our purposes here, we are going to just work with this form of that formula there. But this one is equally correct. It's exactly the same formula as well. Now what we're going to do is we are going to derive a another version of the formula, because this formula is going to be good if we know T1 and we know the common ratio. Okay, so we're going to derive a formula which is going to be in terms of the term number n, Tn. Okay, so the way we're going to do that is here we are going to notice that you see this term here, T1 R to the power n, we got from multiplying this term by r. So if you multiply this term by r, we get this term there. But this term here is Tn. So that means this term here is simply Tn times r. Okay, Tn times r. Okay, so keeping that in mind, we want to remove brackets in the numerator here. So this formula, we're going to write it. So we've got T1 into 1 minus r to the power n over 1 minus r. So remove brackets in the numerator, we've got T1 minus T1 r to the power n. And then this T1 r to the power n is just r times Tn. So we're going to take that and plug it in here. Okay, so that means we can write the formula as T1 minus r Tn over 1 minus r. So this is the other version of the summation formula for a GP. So this version involves the last term, the first term, and the ratio. So here, if we know T1, we know Tn, we know the ratio, then we can find so in this case actually we need T1 r. We also need to know the number of terms here. Okay, so in each case we need to know three things. So here T1, the last term, so that's first term, last term, and ratio, and then we can use that formula there. So those are the three formulas for geometric progressions. Now let's look at some examples. All right, in the first example here, we are going to want to find the formula for the nth term. For each sequence, we're going to want to find the term indicated, and then we're going to want to find the sum indicated. We're going to do C and D, then we're going to go on to number 2. Right, in C we've got first three terms of the sequence 16, 24, and 36. So example C, 16, 24, and 36. We want term number 35. We want the sum of the first 30 terms. So here we need to find T1 and R. Once we got T1 and R, basically then we can find everything else. So T1 is 16 here. R is gonna be 24 over 16. Now 8 goes into 24 3 times, and twice into 16. So this we can keep as 3 on 2, or we can write as 1 over 5. We advise to stick with the fraction form of this, especially in the case where the fraction gives a recurring decimal. In this case, this decimal is terminating, so that's fine. We could use either, but if the decimal is recurring, we'll show an example, we advise that we stick with the fraction. So in part 1, the formula for the nth term is T1r to the power n minus 1. So this is going to be 16 times 3 over 2 to the power n minus 1. And then we just leave it like that. Term number in part 2, want term number 35. So all we're going to do here is simply plug in 35 in that formula. Then we can punch this in the calculator, and then it's at that point that we could write things in decimal form. We're going to use the accuracy of 2 decimal places at all cases here, but it just depends on what your question paper, what accuracy your question paper specifies. So it's going to be 16 times 3 over 2. Then this is raised to the power of, it's going to be 34. So 34, and this is going to give us 15 million. So let's just write it out. It's going to be 15 million 531,835.79. So it's actually 0.80. Okay, so that is the first one there. Then let's go to the third one. Part 3, we want the sum of the first 30 terms. So here we don't know term number 30. So if we wanted to engage this one, we don't know this one. We know term 1, we know r, but we don't know the in terms of this one, we know the first term, we know r, we know the number of terms, so we're going to use that one there. So Sn is T1 1 minus r to the power n all over 1 minus r. So S30 is going to be equal to 16 into 1 minus 3 over 2 to the power 30, all divided by 1 minus 3 over 2. And then all we need to do is just punch this in the calculator. So let's see how this is going to work out. So if we punch this in the calculator, it's going to be 16 times then open brackets 1 minus open brackets again 3 over 2 to the power of 30, and then this whole thing is divided by, so we say open brackets 1 minus 3 over 2, and then equal. So that's going to give us 6,136,001.89. So it's going to be 0.90 correct to 1 decimal place. Okay, so that is part C. We're now going to go to part D. So in part D, we have the first 3 terms are 810, negative 540, and then 360. We are looking for term number 30, and the sum of the first 28 terms. So again, T1 is simply 810, and then R is going to be negative 540, over 810. So it's just 81 over 54. 9 goes into 54 6 times, 9 times there. So this is negative 2/3. Okay. So now negative 2/3, if you express it in decimal form, it gives you a recurring decimal. So this is the one example where it's particularly important to use the fractional form. Okay, so for the first one, Tn is going to be 810 times negative 2/3, not 3/2, 2/3 to the power n minus 1. And then term number, I think we're looking for term number 30, is going to be 810 negative 2/3 to the power 30 minus 1. So we're going to punch that in the calculator and then express it in decimal form. So that's going to be 810, 800, 800, 810 times open brackets negative 2/3, and then this is raised to the power 29. Okay, so that's going to be negative 0.00. Just going to do two significant figures here, so it's going to be 63. Okay, just to show you what would happen if we used an decimal estimate there. So if you go 0.67, okay, then you can see that the number we were going to get is going to be 0.0073, which is very much different from that one. Okay, so we want to round off right at the end. Before then we use the fractional form. Alright, and then we want the sum of the first 28 terms. So it's going to be 810 into 1 minus negative 2/3 to the power 28, and then this is all divided by 1 minus negative 2/3. Then you just punch this in the calculator. So it's going to be 810 times open brackets 1 minus negative 2/3 raised to the power 28. So 28 there, and then this is all divided by, so open brackets 1 minus negative 2/3, and then there is our answer. So this is going to be 485.994, or just 486.00. All right, so we're now going to go to number 2. So let's see what number 2 is about. So number 2 says the second term of a GP So the second term of a GP is 6, the fourth term is 24. Find term number 10. Right, so second term is 6, fourth term is 24. So second term is T2. We're going to want to write this in terms of T1 and R. So T2 is T1 times R. Second term is 6. Fourth term is T1 times R cubed. That one is 24. So what we have here is a simultaneous system of equations involving T1 and R. It's not linear, but we can solve it. So if we call this one equation number 1, this one equation number 2, if we do 2 divided by 1, then on the left hand side we only have R squared. 24 divided by 6 is 4. So from that it tells us that R is either 2 or minus 2. So if R is 2, then we can plug it in here, which means 2 times T1 is 6. So T1 is 3. Okay, so if we know T1 and R, then we can find T10, which is what that question is looking for. So T10 going to be T1 R to the power 9. So it's going to be 3 times 2 to the power 9. Then we can punch that in the calculator. So 2 times, no, it's actually 3. 3 times 2 to the power 9. So this is 1536. So that's the case when R is 2. If R is negative 2, then negative 2 T1 is 6, and so T1 is negative 3. So in that case, T10 is going to be negative 3 times negative 2 to the power 9. And you're going to find that it works out exactly to the same value. But these are two different progressions. The one with R is 2, all the numbers are positive. The one with R is negative 2. The numbers, the terms, you know, they oscillate between negative and positive. Okay, then let's see what number 3 has. In number 3, we have sums. Okay, so I want to find the value of each of these sums. We are going to do C and E. So I'm going to do this one, and we're going to do this one. So in C we've got 15 minus 60 plus 240, etc., and then it goes all the way to 983,040. So let's see how this is going to work out. So number 2C, we have got 15 minus 60 plus 240 plus and then it goes all the way to 983,040. Okay, so T1 here is 15. R is sorry, this is 60 here, not 16. So R is negative 60 over 15. R is negative 4. Tn is 983 and 40. So if we want the sum, we can simply use the second formula. Remember, in the second formula we just need T1, Tn and R. We don't need n. We don't need to know how many terms there are in the summation. So it's a remarkable situation there. So Sn, we are simply going to plug this into this formula. Okay, there is no need for n there. So T1 is 15, R is -4, Tn is 98304, 1 minus -4 there, and then we simply punch this in the calculator. If we do that, we should just make sure you can do that. We're going to find 786,435. So obviously in this case, since the numbers, some of the numbers are positive and some of the numbers are negative, when you add up they cancel out. So that's why the sum of these numbers is even slightly smaller than the last number there, because that number is 900,000 of sorts. This one is 700,000. All right, then let's go to example number E. In example number E, we have got 60 plus 60 times 1.02, 60 times 1.02 squared, and then all the way to 60 times 1.02 to the power 120. Just make sure, yes. So again, T1 is 60 here. R is going to be 60 times 1.02 over 60. So this is simply going to be 1.02. Tn is 60 times 1.02 to the power 120. So again, using the second version of the formula, so the sum is simply going to be 60 minus 1.02 times Tn is 60 times 1.02 to the power 120, all divided by 1 minus 1.02. So here 60 is common in the numerator, so we can actually write this thing like this. So this is going to be 121 now, divided by 1.02, 1 minus 1.02, which you can simply write as negative 0.02. Then we're going to punch this in the calculator. Just show you how to do this. So it's going to be 60 times, open brackets, 1 minus 1.02 to the power of 121, and then this is all divided by negative 0.02. Okay, so this is going to give us 29,941.40, correct, to decimal places. All right, so at this point, what we're going to do is we're going to ask you to pause the video and have a go at the following. Okay, I'm going to pause the video and have a go at these ones. So in number 1, we did E and C and D. So if you'd like to do E and F, And then in number 3, if you would like to do C, D, and F, okay, so just pause the video, have a go at those ones, and then when you press play again, then you can find our answers to compare with, right? All right, we now assume that you've had a go at number 1, E and F, and number 3, D and F. All right, so if you haven't done so, please do so. It's going to be more helpful if you have a look at our answers after having tried the problems yourself. So I'm now going to scroll down to our answers. So for number 1E, the first term to 1 is 4320. The ratio works out to 5/6, and so the formula for the nth term is going to be that one there. So we are keeping this in fraction form. For term number 45, it works out to 1.42. Just for comparison, you can see that if we use the decimal approximation, we get 1.19, which is very much different from this one. So get this one in the exam, you would be marked wrong. Okay, so for the summation, sum of the first 50 terms is going to be 25,917.15. Again, if you use 0.83 here and here, it's going to be 25,409, and you can see this is way way different from that one. So again, in the exam, that would be marked wrong. All right, and then for F, the first term is 320. The ratio is -5/4, so that's going to be your TN, and term number 35 is going to be 631,088.72, and the sum of the first 50 terms is going to be given by that -964,646.86. In part D, this question could be given in a question that does not specify whether this is an AP or GP. So for APs, the differences are the same. Now, if you just try the first two here, you can see that the first one is 16 and this one is 48. So that definitely implies that this is not an AP. And then after that, if you try the ratios, you're going to find that the ratios are the same, so it's definitely a GP. So T1, R, and Tn is known, so we use the second formula. Just plug in here, and this is going to give us 704,584. The same thing here. Looks like there's an error here. There's an error here. This should be negative. Yeah, so that's going to be negative there, and that's negative there. So I'm going to have to recalculate this. So let's calculate it now. So this is going to be 110 times, open brackets, 1 minus, open brackets again, negative 1.1. It's going to be to the power of 101, because that's negative there as well. Okay, so to the power of 101, can say equal, then divided by, open brackets, 1 Well, 1 minus negative 1.1 is just going to be 1 plus 1.1. Okay, so our answer is going to be 794,078.14. So that's the correct answer there. Okay, so and that brings us to the end of this. Thanks for watching. Like our videos, you can subscribe to our channel so that you can get notified whenever we post new stuff. Thank you.